So I couldn't get the file to open without crashing my computer, and it looked kind of complicated. There was kind of a lot of stuff going on in there, so I figured rather than me kind of going through and trying to figure out all the different uh, ways that it was crashing, I just will show you like a basic particle setup and how I try to control the velocity, a couple techniques that I use, and hopefully one of them will work out for you. So the first thing is just a really simple setup. I just have a sphere as an emitter, and then I mean I don't know how you're inheriting the velocity um, in your setup, but for me I like to do as much work in SOPs as possible because I find that once I get into DOP, stuff starts to get a bit more confusing. So um, the first thing I did was I just gave, well, first of all, we should talk about the geometry spreadsheet. Um, you can just add it to your any pane. Um, I think it's really critical to have this open almost at all times when you're working in Houdini because so much of um, issues that come up, you can find out exactly what's going on by using this. And when I first started using this, I hated it because it's like numbers and more numbers, but it's really the best way to diagnose things quickly. Like for example, right now I noticed that there's no normal attribute, and my idea was I wanted to basically make the particles shoot out from the sphere. So the first thing I did was just add some normals using v at n equals at n. And you'll notice that in the geometry spreadsheet right away I see the normals populating. So that's good because that means that like I can visually confirm that I did in fact add normals and everything worked. And if I display them, there they are. So v at n equals at n is just a quick way to initialize some normals, and they'll just point out from the polygons how you would expect. And then I just did v at v equals at n. So to review what v at v, so that's kind of confusing, but v stands for vector, a stands for attribute, and I'm calling it v. So I'm saying, hey, make a vector attribute called v and set it equal to my normal attribute. So notice now I've got velocity attributes here, and they're the same as my normal. So for point 133, its normal values are the same as the velocity. Why do we do this? Well, when you source geometry into a DOP simulation, it knows to look for certain attributes, and v is one of them. So I could have called this like whatever, like barf, right? It doesn't matter. Um, but when um, when Houdini's DOPNet is searching for um, velocity, it's gonna look for v. So this syntax v at v always used to confuse me, but the first v is for vector because you're creating a vector attribute, right? Three parts, right? X, Y, and Z, because we need all three directions for velocity. And then the second v stands for velocity. And then the last thing I did, this don't worry about this. This isn't really that important, but I just because um, if I left this at, this is just a scale that I'm just multiplying the velocity by. Because if I do it like this, it's not really it's not really going crazy, and so I just multiplied it by 5 to make it be a little bit more like maybe what you're dealing with, where the particles are just going like all over the place. So, like first of all, if you have the ability to go back and change stuff in here, like a nice easy way, like let's say for example, my velocity was really crazy. Well, you could just add an attribute wrangle at the end of your geometry, and you could just say v at v, because I'm assuming you have a velocity attribute, because if things are moving in your DOPNet, then that means there is a velocity attribute. And you just times equals, and then you can make a scale for yourself. And what you could do is you could set this to a number like 0.5, and that's going to cut all your velocities in half. And that's much less computationally intensive on your computer than trying to do it in DOPS. So, you know, if that's not an option, there's a couple other ways that we can solve this. So let's say that we are screwed because we've done a lot of work and our particles are getting their velocity from a lot of different places, and it's not just as simple as fixing it in SOPs. So we have this situation here where the particles are going all over the place. So I have two solutions here. One is to use the pop drag force, and I saw on your in your file before it crashed that you did have a pop drag node. So what this is going to do is it's going to try to slow down the velocities of the particles based on air resistance. So if you really want to slow them down, I could crank this up to like 100 and they're barely going to move anywhere. Okay, well, I should talk about this expression first. Let's actually get rid of this. Let's see. I don't want to... there we go. So we'll do activation 1. So now the particles are barely going anywhere. They're just getting off of the surface and then they're coming to a crashing halt. And again, that's because the air resistance is so high. If I turn this to something like 5, they'll have some time to get out, but then they come to a crashing halt right here. Now, what I find to be the problem with the pop drag node is it's kind of like all or nothing. Like if I make this like 1, it's kind of, you can see right where the velocities are starting to slow down out here. And maybe that's what you want, but one thing that I was thinking about was, well, what if I want the drag force to apply for like a second? So I just want to slow the particles for a second, but I don't want to continually slow them throughout the entire simulation. Well, you can say, hey, $FF when you are greater than, let's say 16, and $FF less than 24. So what this is going to do is in between frames 16 and 24, so in between 16 and 24, just for this time period here, that's when you're going to apply the drag force. And I think it's 2 %, but I'm not sure. We'll find out pretty quickly here. I'm actually going to crank this up to like 10 just so we can see. So yeah. So notice what that did is that as soon, actually let's do this a little bit. Let's actually start it at when it's bigger than 24, and we'll stop it when it's less than 48. We'll give it a little bit more time just to kind of see. So initially, boom, and then that was my that part right there where all the particles started slowing down. That was my drag force kicking in. So, if you wanted like an aura, I could see doing something where like maybe you do this like right at the beginning, so you do it like from like 10 to like 16, and then once you have the particles here, what you may want to do, because the problem is that the particles that are getting birthed are going to keep spewing out. But if you had, you could do something like this. You could go to the source node and go to the birth, and we could say we only want it to birth particles. Again, we're going to use expressions. Expressions are just really useful because they just help you control things. Like, I want this to happen now, so I want it to start birthing particles when the frame is greater than 1, and I want it to birth particles when the frame is less than 10. So what that's going to do, and we'll do maybe 200,000 or something like that. So what this is going to do is it's only going to birth particles between frames 1 and 10. So if we look at that, now, okay, that's too many. Well, that's not enough. Yeah, so that's kind of the effect I was going for. So a quick hit explosion. Notice how at the beginning, right, particle 1, or frame 1, that's when my particles are going to start activating, and they're going to stop at 10. So 1 through 10, it's birthing particles. Now, my drag force kicks in at frame 10. So now between 10 and 16, we're going to slow it way down. So notice how all the velocities start to really slow down here. And now, because I'm not birthing any more particles after frame 10, these are the only ones we have left. And they still have some movement, they still have some velocity. It's just that we've dampened it quite a bit, basically. So that's one way to control it. I'm gonna put this back to 1 and just do a constant activation, and we'll do 2,000 maybe. Let's see if that's enough to get. Oh, well, let me actually bypass my pop drag for a second. Let's do 5,000. I think that was what it was. Yeah, there we go. So now we're back to kind of what we had originally. So the other way you can do it is using a pop wrangle node. And I'm kind of doing like a similar approach, but this time I'm using the another attribute. So one thing is that the geometry spreadsheet, when you go to DOPS mode, the geometry spreadsheet starts to look different. And now the question is, where are my attributes? Well, if you go to the pop object and you go and you just find this geometry here, it'll be under your pop object, and you hit geometry. This has all your attributes. But notice how there's so many more attributes now, and that's because DOPS requires a lot more attributes. But there is a bunch of useful attributes here, like age is one that I like to use a lot, because age will keep track of how long the particles have been alive in seconds. So I have a pretty simple little snippet of code here, and all it says is, hey, if your age is less than 1.2 seconds, and if your age is greater than 1. So if we think about it, this is only going to apply when you're between 1 and 1.2 seconds old. So you can think about that. So particles born at 1 second, this is going to kick in. At 1.2 seconds, it's going to stop. And what did I do? I said at v, because I want to affect the velocity, we're going to multiply by 1 over a attribute here, or not an attribute, but a what's this called? A channel, I guess. But called dampener. And the reason why I did 1 over is to make it make more sense. So if you increase this, it's going to dampen more. So if I increase it like to 4, it's going to dampen more than if it was at 2. But basically, what the thing about pop wrangle is that this applies every frame. It evaluates. So if we're multiplying, let's say for example, if we make this 2, then we're essentially multiplying the velocity by 1 over 2, which is 1/2, right? So every single frame that's going by, the velocity is decreasing by 1/2. So think about it, if you start at 10, the next frame you're at 5, then 2.5, then 1.25, and so on and so on. So if I just, like, for example, if I just, I'm going to comment out all these lines here. If I just had this part, then this is what I tried originally, but the problem is that it goes to 0 so fast, because it's basically the velocity is constantly being cut in half. So I was like, well, this isn't what I want. So because the pop wrangle node is evaluating every frame. If I create these conditions um, using the particle's age as a check, basically, to say, hey, are you between 1 and 1.2 seconds old? If you are, I'm going to slow down your velocity by 1/2. And now if we play it, you can see what happens is, well, let me do that again. So right there, right when it's between 1 and 1.2, I just cut the velocity but like crazy. Now they're still moving. You can see they're still moving on the outside. They're still moving slightly, but their velocities have been greatly reduced. Now, let's say I like this effect, but I want to tighten up the ring. Well, I just need that effect to happen sooner, so I could do like, hey, maybe when you're between half a second, or if you're less than if you're greater than half a second, but you are less than 3/4 of a second old. So now you'll notice we'll have like the almost the same effect, but it's tighter. So when you're talking about controlling particles, it's a lot of kind of this kind of thing where it's hard to control every single one specifically and art direct it. By far, you're going to get most of your art direction in your SOPs and your source. I really recommend spending a lot of time on your source and making sure it's exactly how you want and you're getting everything you can out of the source before you start resorting to stuff like this. But it can help. And now for me that's dampening too much, so I'm gonna instead of dampening it by 1/2, I'll dampen it by less. So instead of dividing by 2, we'll divide by like 1.25. So yeah. So that looks a little more. Even that. See, it's still getting too balloony. So maybe let's try 1.5. That feels a little better. You know, if I'm trying to create like an aura around the ball, right? That seems like a little bit more in control. And then what you can do is you can do things like um, let's see. I think there's a pop kill, yeah. So we can say actually, let's do this in our wrangle node. Yeah, because I'll show you why. Because we can say if we can say if your age is greater than, let's say, 4 seconds, then dead is equal to 1. And what that's, oh, I think I have to do @dead. Yeah. So what that's going to do is that's basically going to say, hey, is your age bigger than 4? In that case, I'm going to set your dead attribute to 1. And setting a particle's attribute, dead attribute to 1 just means like kill it, right? Dead 1, kill. Dead is 0. Don't kill, right? It's a true false, 0 false, 1 true. So now once my particles, you'll see they start to die off out here, and you may or may not like that. You know, it's just like a lot of personal preference. I'm just trying to give you as many options as possible, and you can pick and choose which techniques you want. Anyway, I hope this is helpful. Feel free to hit me back on Discord if you have any questions. I try to show examples like this on really simple setups, and I know sometimes, I mean, that scene looked pretty complex, and it might be kind of hard to figure out like where to put this stuff in, but I did notice there was a pop drag node somewhere, so you could even just start by cranking that up and seeing if that fixes your problem. But what I really recommend doing is going into this geometry spreadsheet and going to the velocity, or heck, even let's see, is there an acceleration attribute? I thought there was, but anyway, you could go to the velocity attribute, right? And so if I take this off and I just go with what I had, notice how all of my particles, or a lot of them, have velocities approaching, you know, 5. Like, if I sort, right, in general, my values go from about -5 to +5. So that's pretty high velocity, right? So if I could go back to my emitter, and just by cutting this down to like zero point 0.5, for example, now all of a sudden when I get to my DOPS, um, now notice my velocities, the range that they go from is zero point 0.5 to -0.5, zero point 0.5, so that's much tighter. And we're gonna get like a slower expanding. But again, like you still run into the problem where everything's drifting out forever and ever. So you're still gonna have to like do either like a pop kill or create some condition where if they get a certain distance away from the origin, you kill it, or like there's different things you can do. But the important thing is to just like mess around with it. Um, try different things. These are just some ideas I came up with, but I'm sure there's better ones. And again, maybe if you're looking for like a really really specific kind of look, then maybe send me a video of like what you have in mind, and I might be able to uh, have like a better idea of what you want. But all I got was the particles are going crazy, and I want it to look like an aura. So based on that, that's kind of where I came up with these solutions. Anyway, hope this helps, and hopefully we'll talk again soon.